Can you hear me okay?
Yeah.
Okay, good. Hello, my name's Nick. I'm from the UK. If you hadn't noticed already, it doesn't take us a moment. Although the taxi driver last night thought I was from Australia, but that's another story. It's a pleasure and a privilege to be here. This is my first Birmingham, and I'm thrown straight into to the privileged position of speaking with you. This is my amplifier that I've built. I'm going to tell you the story behind that. It's sitting on the bench over there if you want to take a closer look. But I feel like a tour guide. On your left is the Taj Mahal, on your right is the... anyway, you get the idea. All right, so what is this and what am I doing? The amplifier in a nutshell, it's another hybrid tube lateral MOSFET. Sorry, Dennis, you'll be sick of these by the end of the day. It has tube, phono, and preamps based loosely on Marantz 7. It's a circuit.
Can you show the amplifier one more time?
Please, what was that?
Could you show the amplifier one more time?
Can I show the amplifier one more time? Of course, there is the amplifier. Okay, great. Okay, so in a nutshell, as I said, this is a hybrid tube and lateral MOSFET integrated with a tube, phono, and preamps loosely based on the Marantz 7. And the Marantz 7 is fairly, I guess it's been talked about a lot. There's nothing really new to talk about there. So most of this is, my presentation is going to talk about the power amp, which is a Class AB lateral MOSFET amp with a Class A BJT stage in parallel with it. This is inspired by something called the GEM amp. And I don't know if anyone's ever heard of this, but it was created by a guy called Graham Maynard. And Graham Maynard I will talk to you about in a second. Some of you may know the name, but we'll come back to that. Other features this amplifier has got, it's got an output for an additional power amp, because it's something you don't find on amplifiers these days. I wanted that. You never know what you're going to plug into it. It has auto power off. So after about 50 minutes of doing nothing, it turns itself off. And on again if you play a signal into it. Even with a vinyl record, you can play a vinyl record, just put the vinyl record on, it will come back on again. Sounds a bit pointless, but it's kind of fun to demonstrate. It has an EQ toggle switch. It has a filter and a preamp that I based loosely on a sort of a loudness circuit. It's kind of loudness light. I like it. Just gives a bit of bass boost to your sort of heavy metal and all that sort of stuff that you like to listen to. It's about 120 watts per channel, probably. I haven't analysed it. That's what it looks like with the lid off. There's a lot in there. A problem I will talk to you about in a bit more in a moment. And that's with the lid on again. So 6 tubes. There's a phono amp, preamp, and heat sinks. Looks a bit like a Hafler, doesn't it? That's the block diagram. So just so you give you an idea of what's in the box. As I said, the phono stage on the left. Through a selector switch. There's also line inputs there. Volume control. Preamp, again that's tubes. And then into this GEM amp derivative, which I'm going to talk to you about in a second. Okay. Why bother? Why bother making your own kit? I've really recently got back into this in the last 3 years or so. I used to tinker with electronics when I was a student, but modern mainstream amps in 2016, when I got back into vinyl, they just sounded really underwhelming. And I was going out and spending the equivalent of what you'd probably call $400 or $500, I suppose. And I was taking it back to the store going, no, that sounds rubbish. I got interested in vintage equipment. Long story, but a guy offered me for nothing a Technics SUV2. I bought it. I went, wow, that sounds. This is much better than this stuff I've been buying for $400 or $500. And I just got into collecting the stuff, trading it on eBay. And long story short, my sort of research and investigation led me to my dream combo is going to be a Hafler DH200 with a Marantz 7. I've never heard either of these amps, but this is what I thought I wanted. But I couldn't find these affordably in the UK. This just wasn't going to happen. Right? No one's got them, and if they have, they're very, very expensive. You get the idea. So I was going to have, if I wanted this, I was going to have to build this amp. I skipped one. What I really wanted was a tube phono integrated with a Class A output, and this didn't exist. So I guess I was going to have to build it. And I found a really good mentor to help me. While I was trading some of this stuff on eBay, I met this guy, Henry Dulat, who's turned into my mentor. He's also into motorcycles. That's a Norton motorcycle piston. For those of you know your motorcycles, obviously you knew that. He's known on the UK forums as top repairman. He's the kind of go-to guy in the south of England for esoteric power tube amps, and he knows more than pretty much anyone I've met before, and he's very trustworthy. Everyone likes his work, and he's become a very good friend. A couple of other people I'd like to make a shout out to that have informed my project. Doug Self, I'm sure some of you are familiar with his audio power amplifier design book. My amplifier follows this long tail pair topology to an extent. Also to Rod Elliott of ESP, his online resources have been invaluable to me. Not just for amplifiers, but other control systems in your amp, soft start, speaker protection, things like that. Really, really good site. Very generous man. I'm indebted to him. I mentioned Graham Maynard a moment ago. This is the guy for whom this is really in the memory of. He passed away in October 2014. He was a UK-based DIY audio and radio enthusiast, creator of the Gem amp, like I said, which I'm going to show you in a sec. Respected contributor to DIYaudio.com. He was, I've seen some of his posts on there, but obviously he's not been around for a while, but you can read more about his stuff at boven.net, which is where his family and friends preserve his memories and projects. And it's not just amplifiers, he's come up with some pretty interesting stuff. This is the Gem amp. That's Graham's original schematic. I'm going to try and bluff my way through what's in here. You can see a long tail pair topology. You can see there's a class A, B stage there. There's actually a single-ended class A output there with a current source somewhere up there. There's a local feedback loop at 27k, balanced by 27k there. Okay, I'm trying to describe some of this as schematic, it's almost impossible, but you get the idea. It's two output stages in parallel. Quiescent current is about 600 milliamps, indicated at the top there. And I'm informed by Zenmod that Carlos from Brazil, one of your DIYaudio.com colleagues, built one of these and was really impressed with it. So there's some history here, and one of the reasons I wanted to share this with you because I wanted to take this to do some work on it and see if we can sort of keep this project moving because it's an interesting little thing. Graham's mission with this, he wanted to achieve the sound of the John Lindsley Hood 1969 Class A design. This is something he really coveted. And that's that circuit there for anyone that knows it. I've not built it. 1969 Wireless World, I think, article he published this in. What Graham wanted to do though is he wanted to get 100 watt, 200 watt power to sort of drive the kinds of speakers that were being built in the 70s and perhaps the 80s. He needed Class A-B power to do this. Now Graham believed that crossover distortion in Class A-B was made worse by the back EMF from loudspeakers. He said that this is not visible when you're testing the steady sine waves into resistors, but it is present with real music, the transient back EMF in real music. And so his thinking was a parallel Class A stage would mitigate the effects of back EMF, smoothing the crossover region and improving the sound in his opinion. This is a similar idea to things like the Quad 405 current dumping design from the late 70s, which is patented in the UK. Again, more info at boven.net, and these slides will be available after the show. Again, we've done the Lindsley Hood. So my challenge was I wanted to get this to work in my Zinamp integrated box. The Zinamp, by the way, it's not Zinamp. I don't want to be taken to court for anything. Sorry, the Zin is actually the Zinfandel grape. There's a story behind that because I believe that making amplifiers and audio is very much like making and drinking wine. That's another conversation, but that's what Zin is. So in my box, I've got respectable heat sinks, but not the kinds of things perhaps you may have in monoblocs. I haven't got a lot of space. I don't have space for big heat filter capacitors. So all the problems of noise and hum are going to come and bite me, followed by just filling it all in there. Like Dennis said, you've got to sort of be innovative, but also to keep it simple. Sorry, couldn't resist. Anyway, okay. So I've got some design decisions to make. I could just copy what Graham did, but my mentor, Henry, the motorcycle guy, said that why don't you make it push-pull? So I said, okay. It should require less quiescent current that way and probably get cooler running. So we did that. I went for the lateral MOSFET AB stage. Graham's circuit was a BJT. I'd already done some work in the sort of trying to ape what Haflin was doing with my amp and was following what Doug Self was doing. So I was kind of allied to that. And it requires fewer components, more thermally stable, etc. Yada yada. I've got to keep it simple. It's in a small box. Keep my life easy. I also needed a regulated power supply. I read, going forward a bit, I think there's a guy called John Broski here, anyone knows him. He did an appraisal online on TubeCAD of the Gem amp, and one of the things he said was you would almost certainly need a regulated power supply to run it. One of the other problems as well is that there's a feedback loop in the Gem amp which feeds back into the negative rail. He suggested that would get very noisy at high volumes with all the sort of noise in the negative rail, so we took that out. And this is what it looks like. Okay, I took the component values out, not because I'm being secretive, I'm more happy to share, it just makes it easier to look at. You can guess most of this stuff, but Class A, B stage, Class A stage and push-pull. Okay? this is all fairly familiar. Dennis has talked about long-tail pairs inputs, all that kind of stuff. There is some local feedback there, which has to be balanced by this arrangement here, otherwise all the voltage is going off like that. This also doubles up as a nice offset control for the speaker offset. And anyway, okay, so the challenge I had was how to drive this Class A stage in push-pull, because Graham's circuit was originally single-ended. This TIP36C, it says that there was not driven in Graham's circuit. Now, what I have here is I'm going to move on a slide, it's a bit simpler, I boiled it down. You've got a VAS here, and this has a follower, and in Graham's circuit that's split to run the Class AB stage and run the Class A stage here. Now I've kind of run out of outputs, I need a third output on a transistor to drive this thing up here. Well, I haven't got one. So I kind of looked in the simulator for a while and I went, for about half a day. And suddenly it emerged, why don't I just take that, run another one in parallel, and run it upside down with a beat strap off the negative rail, because there's a beat strap off the positive rail and the other follower. So we got opposites. And that quite nicely drives the other side of the Class A arrangement and push-pull. And it seemed to work on the simulator. So I got a PCB made and gave it a go. It sounded really good, and the PCB looks like that. So it's kind of quite neat. In the middle, Hexacon MOSFETs that Dennis was talking about there. These are the double die types. So there's two devices on each one. They're a nice product, and they're readily available in the UK. There's the TIP35 and TIP36C on each side of the PCB there, which are the Class A devices. Various trimmer pots to sort of stop things going crazy and blowing up. I also needed a regulated supply. This is it. Anyone familiar with the circuit or not? Based on up there, Q1, that's actually a Darlington. It's a great big 15-note Darlington. There's one down here on the negative side as well. So you basically, most of it's N on that side and P on this side. It's like a mirror. You get about 48 volts out of this. So the idea is that a Zener there gives you a reference voltage, and your output is basically double the Zener voltage multiplied by the ratio of R4 and R5. So that's 10 over 8.2, so it gives you about 48 at the output and minus 48 there. Works kind of nice, and the capacitors only need to be about 2200 microfarads. So you end up with a PCB which looks like that. So it's not too big, it's quite neat. And it doesn't hum and buzz. I'll tell you what, I ended up with a garbage can full of Darlingtons after building this and trying to get, honestly, turn it on, boom, until I got like 15 amp Darlingtons on each side. It was just a nightmare. So especially the speakers part, it was boom. But no, those days are behind me, thankfully. Self and biasing. Obviously, I mentioned that I have a huge heat sinks, and heat's going to be a bit of an issue. So my aim was really to maximise the amount of Class A current without the thing overheating. I'm using double die FETs as well, so I've got a bit more AB current to think about as well, so I don't want to let that get out of control. Now it's tempting to think, if you think back to what Graham was saying about using the Class A stage to straighten out the crossover distortion, it's tempting to think, well, my Class A stage would just mop up the crossover distortion from under-biased FETs. It doesn't work like that at all, I found. So I was trying the FETs biased at around 70 milliamps, just sounded chalky. I found a sweet spot. I biased the FETs to about 75 milliamps, or in fact, because they're double die, it's really 150. The Class A biased to about 200. It sounds nice, and it doesn't run too hot. After about an hour of running, you do the old, I think it's the Nelson test, isn't it? 5 seconds with your hands on it. It's about, I don't know what, I've got it written on the slide, because I've got to convert Celsius to Fahrenheit, apologies. But it's not too hot. The Class A stage, incidentally, is generating most of the heat. Now, there's a temptation to try monoblocks with this, bigger heat sinks, more current, turn up the dials, Igor, and all that. I'm sure that we can improve it. So bias, as I said, biasing, you put your meter across your biasing resistor. This is the transfer curve for the Hexacon MOSFETs. I said at the chalky and cool region there is in the red, and that's with about 700 millivolts across our bias. It gets good, but a little bit warm. It sounds good, it sounds nice, which is where I have it most of the time, at about 900 millivolts. You could go up a bit. 1200 millivolts is probably better, and yeah, as I said, knock yourself out. We can have some fun with this. There are some trade-offs though. Every design has some trade-offs. The rails, you really can't take them beyond about 48 volts without encountering heat issues. I did try a 58 volt version to try and get more power. They got very sweaty. I had about 160 Fahrenheit on the heat sinks. So I guess we're probably limited to about 120 watts music power, but how much power do you need? I don't know. You tell me. Push-pull Class A versus Graham single-ended. This gives us better rail rejection. Not that I really need it, I suppose. I've got a regulated supply. I'm running lower current in my Class A, so a bit less heat. Now you might think also the lower second order harmonics might be no longer predominant. Got a bit of feedback there. Running push-pull, we may have less of the second order harmonics than we would with single-ended, although the Class A stage are only providing 1 watt, I don't know. But this is work in progress. Subjective listening, very, very good, I like it. Although full measurement analysis is required. Now, I want a big shout out and thank you to Bob Cordell yesterday in the measurement workshop, because Bob very kindly helped me measure the amp there, and we think the total harmonic distortion, this is going through the preamp and out the power amp, was about 0.07, and it looked like mostly lower order second harmonics as well, so I got a pair of little sunglasses on for that. I couldn't resist. So yeah, I was like, argue with that. And there were some technical issues as well in the measurement. So we got some more to do on that. I'm super stoked and excited about that. So how does it sound? Well, I think it sounds really good. I would say that, wouldn't I? I've come all this way. It's a definite. I think it's a step forward from the Class A B amp that I had previously. I'm not saying it's a step forward from any other Class A B amp that you may have built, but certainly from what I was doing. So I don't think I would go back. It gives a sense of space between notes and sounds without that sort of smeariness. Now I'm quoting Graham there, Graham Maynard, the creator of the Gem. I think in the modern equivalent might be saying the blacks in a picture of a good plasma TV screen. Maybe plasma TV screens are the tube amp of the TV world. I don't know. But I like, as a former musician, I used to be a drummer. I noticed that vocals and drums sound particularly lifelike, especially bass drums. And you can sort of just hear timbres and things that perhaps weren't immediately present before. And of course, my wife likes this amp. Dennis, you were saying about, when she says, that's right, and she's got better hearing than I do. Oh gosh, all right, anyway. I'm sorry?
Does she come running from the kitchen?
She doesn't really cook that much, so she comes running. It's not always from the kitchen. She'll probably get to see this, so honey, thanks. Thanks for all your encouragement, and it's been awesome. So yeah, I think it really sounds good, and I like it. And please come and listen later. I hopefully maybe at 3 o'clock back in the other building we'll have a chance. But please, that's it. And if you've got any questions, yeah, thanks. Anyone? Please.
What are the tubes?
The tubes are what the original Marantz 7C had. So those are 12 AUX7s and 12 and 12. There you go. There's a pair of 12 AX7s in a feedback loop and a follower 12 AX7. There's a follower in both of those. That's the phono amp and that's the preamp. If you know that circuit, I think that one's been done to beyond what I can say about it. But it was a project I picked because it was it was nice. I actually got some boards from another project that I tried, and I really liked them. But there were some things missing for me. There was no EQ control on the preamp, so I added that. So I rebuilt these to my own sort of requirements. Yeah. I know we're out of time. I would be flattering to have lots of questions and stuff, but please, come on.
Could you describe your design environment, the tools that you use?
Yeah, it's really simple. I'm not even using Spice. It's really embarrassing. I'm using a piece of software on a Mac, a simulator, which is, I think it's called iCircuit. It's not even supported anymore. But it's just something I got moving with and stuck with because it worked for me. I use Easy EDA as a design and fabrication tool for PCBs, and Easy EDA. I cannot recommend it enough. It's coupled with a company called JLC PCB. If you want to get prototypes PCB delivered by DHL or UPS, you can turn it around in a week. You can turn it back around in a week. It's really, really good. So you can iterate and prototype, and it's not horribly expensive either. I just like to. I work in software and IT, and I come from a background where we're redeploying and continually, and this idea of just trying something prototype, and releasing often. It really appeals to me. So that's really where I've gone with this. Easy EDA. It's free to use and it's awesome.
Thank you.
Welcome. Thanks very much. Okay, I'm going to hand over to Bob now. Is that right? Bob is the next speaker. So, thank you very much.
Thank